Hello and welcome to IB and A-Level Learning Center. In this video, I'm going to help you to solve a problem in mechanics paper, A-Level mechanics paper in March 2023. This is question 7, the last one and the hardest one. The diagram shows a smooth track with lines in a vertical plane. The section AB is a quarter circle of the radius 1.8 meter. With the center O, the section BC is horizontal straight line of 7 meters and OB is perpendicular to BC. The section CFE is a straight line inclined at an angle theta above the horizontal. A particle P of the mass 0.5 kilogram is released from rest at A. Here, this is a particle named B. And then this particle P collides with the particle Q of the mass 0.1 kilograms, which is at rest at B. Here, another particle Q here. And they can move, they can slide smoothly because I don't see any information about the friction on the track ABC. There's absolutely no information about friction, so I assume that the friction is negligible. Immediately after the collision, the speed of P is 4 meters per second in the direction BC. Question A. Show that the speed of Q immediately after the collision is 10 meters per second. Okay, to prove this thing, to find the speed of Q after the collision, we need to use the conservation of momentum, because anytime a problem in mechanics and also in physics mention about the collisions, that is like 99% definitely that we have to use the conservation of momentum, because momentum is always conserved in both cases. Collisions, including both types, elastic collision and inelastic collision, and a second type is explosion. Okay, so for this collision we have to use conservation of momentum, but before doing that we need to find the velocity, the speed of the particle B when it slides down and reaches the bottom. To find that, we have to use the conservation of energy, mechanical energy. With the zero level of potential energy at the surface BC, the particle B starts from A, which is 1.8 meter above the ground. So its initial mechanical energy is gravitational potential energy. We are now doing the conservation of mechanical energy. The initial energy of the particle P at the point 8 initial position is gravitational potential energy, which is mgh. M here is the mass of the particle P. Okay, and after sliding down this curved track and reaches the bottom B, all that potential energy converts 100% into kinetic energy, 1/2 mp and vp squared. Because the friction is negligible, again there is no information about friction, so we ignore that thing, friction. So we can simplify the mass on both sides of the equation and then find the speed of the particle B, P, right before hitting the particle Q. So G here is 9.8 and the height is 1.8 meter. The speed VP here is what we need to find. So VP is simply the square root of 2 times 9.8 and 1.8, and it will be equal to 21 square root 2 over 5. 21 square root 2 over 5. Here I do not use the rounding, do not do the rounding, because when we do the rounding too many times, too many steps in a problem, the final answer could be quite different from the actual calculation. So we avoid rounding too many steps, but only one last step to 1 or 2 significant figures according to the given information of the 2 significant figures. Okay. The next step, we need to use the conservation of momentum. Conservation of momentum for the collision. Momentum. And this momentum is elastic, definitely, because again there is no friction, and therefore the mechanical energy, actually the kinetic energy of the two particles before and after the collision is the same, is constant, and therefore this collision is called elastic collision. And the conservation of momentum is written as follows: the mass of the particle P multiplied with its speed, which is from its velocity, its velocity from the left to the right, and its velocity has the magnitude here 21 square root 2 over 5 meter per second, moving from the left to right. Okay, and then the momentum of second particle, the particle Q, is initially 0 because it was stationary, and then this particle P has a remaining velocity after the collision VB dash, which is 4 meter per second here after the collision. Okay, and then we write another momentum Q of the particle Q after the collision, and we need to find this thing. Okay, this thing will be easily solved, will be found by solving this equation, plugging the values, the numbers into the equation. The mass of P is 0.5 kilograms, the speed, the velocity here 21 square root 2 over 5, and then equal to 0.5 here. The speed after collision is 4, given one significant figure, that's where. Okay, and the mass Q here is 0.1 kilogram, and this is VQ dash after the collision that we need to find. Solving the equation with the calculator. Okay, 0.5 here multiply with 21 square root 2 divided by 5, and then we need to subtract this one. Subtract 0.1 times 0.5 times 4, and then lastly, after doing this calculation, divide 0.1 here to get the speed Q. Oh dear, 9.69, 9.7, 9.7 meter per second, and is approximately equal to 10. Approximately equal to 10, 9.7, and the question asking us to prove that this speed is approximately equal to 10. Okay, so we can write that equal to 10 meter per second. So the first question is solved already. That is 4 mark. Now moving on to question B. When Q reaches C, which is the start of the incline going up, and sliding 7 meter before that, it collides with the particle R of the mass 0.4 kilogram, which is at rate as C. Another particle R here. Okay, I forgot to tell you one thing. I did not draw a particle as a sphere, but a rectangular block like this. The reason I avoid drawing a sphere is because I don't want to involve the calculation of the rotational kinetic energy and the moment of inertia of the object rotating, and therefore I assume that these particles are like the block sliding with only the translational kinetic energy. The combined particle comes instantaneously to rest at F here, which is not the top of the incline, in the middle of the incline. They come to stop there in the middle of the incline. You should assume that there is no instantaneous change in speed as the combined particle leaves C, nor when it passes through C again and it returns down the slope. Given that the distance CF is 0.4 meters, find the value of the angle. Okay, the value of the angle. They come to stop after sliding a distance of 0.4 meter. Again, that distance 0.4, this system, the two blocks stick together, will decrease, will decelerate, will slow down when going up the incline. Again, I need to emphasize that the friction is negligible, and therefore again we can use the conservation of energy to find the relationship between the speed of the system at the bottom of the incline and the height it goes up to. Here's the diagram, the distance CF that it traveled, which is 0.4 meter Okay, and I'm talking about this height. We can find this new height, this new height simply using the relationship, using the trigonometry, the sine and cosine. Okay, so the initial kinetic energy of the system of the two blocks stick together, which is the mass of Q plus the mass of R, and times their velocity at the position C. So where this is the velocity of the system of the two blocks stick together. Okay, so we have to find this thing first, and therefore I put a empty space here to find that, earlier. This kinetic energy will be equal to the gravitational potential energy at F, which is the mass of the system mq plus mr, and then times g and times this new height. Okay, and this new height we can calculate that by trigonometry, sine, the distance 0.4 meter multiplied with sine of the angle theta. We are asked to find the angle theta, so to find that we need to find this distance h dash using the conservation of energy equation here. Okay, now going back to the first step, which is finding this speed. Again, we use the conservation of momentum. Now we have the two blocks Q and R colliding and stick together, which is inelastic collision. Okay, but basically the equation for the momentum conservation is the same, which is the mass of Q multiplied with its speed, which is VQ, which is 10 in the question A part. Okay, and then it is equal to the mass of system MQ plus MR times the speed of the system V here. Now plug in the value. MQ is 0.1 kilogram, VQ is approximately 10, taken 10. Okay, this is 0.1 plus what is the mass of R? It is still 0.4 kilogram here. The mass of R 0.4 kilogram. So the sum is 0.5, huh? Speed V here. So the speed V here is here 1 divided by 0.5, 1 divided by 0.5, which is 2, huh? 2 meter per second. Okay. Now, going to the second step. Now, plugging the value of the speed here into this equation to find the new height. Okay. Oh, sorry, I forgot the 1/2 for the kinetic energy here of the system. 1/2 mv squared, huh? Okay. So now plugging the value into this one. 1/2 the mass of Q and R combined is 0.5 kilogram. The speed here is 2. Square it. And the mass here is still 0.5, G is 9.8, and the new height. Now finding the new height. The new height will be approximately equal to 0.2 meter, and it is equal to here 0.4 for the length CF multiplied with sine of the angle theta, and therefore we have sine of theta will be equal to 0.2 over 0.4, which is 1/2, and therefore the angle theta is the inverse sine of 1/2, which is 30 degrees. Okay, 30 degrees. So this is the answer. Again, this is the first mark, the second mark for finding the speed, the third mark for writing the equation of the conservation of energy, third mark here for this equation. And lastly, solving it, plug in the value and find the angle. So that is 4 marks for this question. Lastly, question C. Find the distance from B at which the particle P collides with the combined particle. Note that the particle B has a very low speed, which is 4 meters per second here. 4 meters per second, meaning it moves very slowly, 4 meters per second, compared to the particle Q moving very fast with a speed of 10 meters per second. So Q will move ahead. VQ here is 10 meters per second. Will move ahead very quickly from B to C, and then collide with R, combine with R, go up to F, and then slide down again because of the pull of gravity. So to find the position that P collide with QR, it could be here. The 3 particles can collide here. The 3 particles can collide here at this position. And to find the distance from this position to B, firstly we need to find the position of the particle B. For example, it is here. When the particle Q hit the particle R at C. Okay, the time it takes Q to move from B to C, we take that distance 7 meters divided by the speed of the particle Q, which is 10. So that is 0.7 seconds. And when Q at C, when Q is at C and colliding with R, the particle P slides or move a distance. The distance, which is the distance, I can call that the new position is M somewhere, 0.7 seconds after the collision between B and C. So this distance is the speed of P, which is 4 meters per second, multiplied with the time 0.7 seconds, and it's a 2.1 meter from B. Okay, the particle P is here, 2.1 meter. When the two particles Q and R collide, okay, it takes the system QR time, which we will find right now, a certain time to go up to F and then slide down, and then going back in opposite direction from the right to the left and collide with P again. Okay, so the time for the two particle QR to move to F is, there is an acceleration, which is the deceleration because of the pull of gravity slowing down the system, and finally will make it slide down the incline again. To find this term, I will use an equation in the SUVAT, the big five equation in kinematic, which is the distance s that it moves equal to the initial speed plus the final speed divided by 2 and multiply with the time. Okay, this half u plus v is the average speed. The distance cf is 0.4 meter. U is 2. We calculate in part B. U is 2, and v, the final velocity, is 0, and divide 2 and then multiply with the time. So we can find this term. This term is found by, okay, so here 0.4 times 221 is the time is 0.4 second. Okay, 0.4 second, and it would take the same amount of time to slide down from F to C because the acceleration is the same time, 0.4 second for Q and R to slide down from C to F, from F to C again, and therefore total time for the system QR to move from C to F and then return to C is 0.8 second. Okay, 0.8 second. And during this time, during this 0.8 second, P travels another distance, which is 4 meters per second. Its speed multiplied with its time. so long. Okay, which is 3.2 meter. Okay, now the distance of P, let me draw an illustration here. So this is B, the bottom of the surface. It already traveled 2.1 meter up to here M, 2.1 meter. Okay, and it traveled another distance 3.2 meter up to here. The new position, I call it N. Okay, and here the position C. The total distance BC is 7 meter. Okay, so it's a little bit closer to C. C could be like here, sorry. Okay, because we take 7, subtract 1.2, 2.1 and 3.2. Now at this moment the particle P is at N when the two particle QR is here, and the distance NC between them is 7.0 minus 2.1 and minus 3.2 meter. Okay, 7 minus 2.1 minus 3.2, it is 1.7 meter. 1.7 meter. We need to find the distance from B that they meet each other. For example, here, this new position, the final position, let's call it D, destination. Okay, I will assume this letter D. This is where they meet, and to find this position, we need to write the two equations for the position of the two particles. For the particle P, starting from N here. Now we consider the moment that P is from N. The new time, okay, position of P will be 0.4, which is its speed multiplied with the new time T dash. This new time T is from this moment when it is at N. It is at end, and then moving to the final, position where they collide. Okay, and for the particle QR system, they are moving in the opposite direction with the same speed, which is 2 meters per second, which is the speed that they collide after the collision and going up the incline, 2 meters per second. The speed will be the same because there is no friction. The energy, mechanical energy, is conserved, and therefore when the kinetic energy converts into the potential energy at the top, it will convert back into the same amount of kinetic energy when the system returns to the position C. Okay, the speed is the same, 2 meters per second, but it is now moving in the opposite direction from the right to left, and therefore I put a negative sign here. Multiply with this new time, new t. Okay, so this is the distance they travel, but in the opposite direction. Okay, the distance they travel. Anyway, so for distance, I will remove the negative sign, and when they meet, the total distance that they travel will be 1.7 meter here. So when they meet, again, these things are their distance, the distance they travel. Okay, when they meet, the total distance they travel is 4.0 t dash plus 2.0 t dash will be equal to 1.7 meter. And therefore I can solve this equation to find the time t dash. T dash will be equal to 1.7 divided by 6. 1.7 divided by 6, which is 0.28 second. And so the distance, so ND will be 4 times 0.28. Take this value, do not round it. Okay, multiply with 4. We have the distance ND, which is 1.13 meter. 1.1 meter. I round only one time here, a meter. And lastly, conclude that the distance dB is what we need to find. The final conclusion, and BD will be 2.1 meter plus 3.2 meter plus 1.1. Okay, 6.4 meter, 6.4 meter. This is the final answer, 6.4. Checking mark scheme. Distance is 6.2 third. 2 third is about, what is the value of 2 third? 2 third is 6.6, a little bit, so my answer is a little bit different from the solution of the mark scheme, but I think this is close enough. I think it's acceptable. So the point is understanding the solution, and then you can change the way that you write the solution a little bit, make it shorter but easy enough for the readers, the grader, the teacher to grade the mark. Okay, thank you for watching, and I hope to receive any comments in the comment below. Thank you.